Hello everyone, good morning, good afternoon, or good evening, wherever you are. Today we're exploring a fascinating topic at the frontier of AI, machine unlearning. How we teach machine learning models to forget specific data or behaviors. We'll cover what it is, why it matters, how it works, and what challenges lie ahead. If you're interested in the future of AI, privacy, data governance, or model engineering, this video is for you. So what exactly do we mean by machine unlearning? In traditional machine learning, models learn from data. They accumulate knowledge, patterns, behaviors. But what if you need a model to forget some of that knowledge? That might be because the data was sensitive, incorrect, copyrighted, or simply no longer relevant. This is where unlearning comes in. According to research, machine unlearning is the process of removing or minimizing the influence of specific data points or concepts from a trained model without rebuilding it from scratch. It's more than deleting raw data. It's about erasing its effect from the model's behavior. Why is unlearning so important? There are several reasons. Privacy and regulation. In jurisdictions like the EU, individuals have the right to be forgotten. Models trained on personal data may need to erase that data's influence. Copyright and licensing. Models may have been trained on copyrighted material. Unlearning can remove reliance on that content without full retraining. Bias, toxicity, and erroneous data. If a model has learned unwanted behaviors or harmful content, unlearning can help mitigate that. Efficiency and cost. Retraining large models from scratch is expensive. Unlearning offers a more efficient alternative. To understand how unlearning works, we need to clarify some key concepts. Forget set, the subset of data we want the model to forget. Residual influence, the lingering effect of that data on model behavior. Exact unlearning versus approximate unlearning. Exact means the model's behavior is as if it never saw that data. Approximate means the effect is minimized. Computational unlearning, a strong definition where an adversary cannot distinguish between a model retrained without the data and one that underwent unlearning. These definitions help us frame the techniques and evaluation methods. How do we make a model forget? Researchers propose several techniques. Retraining. Simply remove the target data and retrain the model. This is the brute force approach, but extremely costly for large models. Data removal and fine-tuning. Remove the data and fine-tune the model on remaining data. Less costly, but may not fully remove influence. Parameter manipulation/pruning. Adjust weights, prune neurons associated with the forget set. Shard-based methods. Partition data into shards, so forgetting one shard is cheaper. For example, the SAFE method uses shard graphs to minimize forgetting cost and utility loss. Black box unlearning methods. Don't require internal access to model, e.g., prompting or input adjustments to make model forget specific classes. Let's walk through a hands-on example to illustrate. Here is a case study. Researchers at University of Texas applied machine unlearning to a generative model to remove copyrighted and violent content. They achieved content removal without retraining the model from scratch. Another example. IBM's work on LLMs showed that unlearning could reduce toxicity from 15.4% to 4.8% while preserving performance. These examples show that unlearning is not just theoretical, but practical, although major challenges remain. How do we know a model has successfully unlearned? We need evaluation metrics. Membership inference tests. Can an adversary tell if a data point was in the training set? KL divergence or distributional metrics. Measure difference between the unlearned model and a retrained model. Utility/accuracy trade-off. Did the model lose general performance when unlearning? Time and compute cost. Unlearning must be efficient to be practical. There are no universal benchmarks yet, and this remains an area of active research. Even though the field is advancing, several key challenges persist. Complete forgetting guarantee. Achieving exact unlearning remains difficult. Many methods only approximate. Scalability. Large models with billions of parameters make unlearning expensive and complex. Utility degradation. Unlearning might erode overall model performance if not done carefully. Regulation and legislation. How do we enforce and audit unlearning practices under laws like GDPR? Tooling and maturity. The ecosystem of unlearning tools is still emerging. In short, while model unlearning holds promise, it's far from solved. If you work with models and data, here are practical guidelines to incorporate unlearning. Data governance. Label and track data provenance. Identify sensitive or removable data early. Model architecture design. Consider modular or shard-based designs that allow for efficient unlearning. Monitoring and audit. Regularly test for unwanted memorization or leakage. Unlearning protocols. Define processes for removal of data influence, including trigger, method, verification. Balance utility and forgetfulness. Always measure model performance after unlearning to ensure you haven't degraded core capabilities. By building these into your ML lifecycle, you'll be better prepared for this emerging demand. Looking ahead, what's next for model unlearning? We can expect more standardized benchmarks and evaluation frameworks, better tooling and APIs that enable unlearning as a built-in capability, integration into MLOP's pipelines and compliance workflows, wider use in private LLMs, generative models, and federated learning environments. In essence, unlearning may become as important as learning in the AI lifecycle. The ability to forget may define trustworthiness in future AI systems. Thanks for watching. We've covered what model unlearning is, why it matters, how it works, where the challenges lie, and how you can start preparing. If you found this video valuable, please like, share, and subscribe. It helps me bring more deep dive content like this. Leave a comment. Do you think we'll ever reach perfect forgetting in AI models, or is that science fiction? Until next time, stay curious and keep exploring the frontiers of AI.